Okay, so after discussing the real number systems at a grade 10 level, and if you've already watched the LCM and HCF video from grade 9 and the fractions video from grade 9, we can now move on to talking about rounding off and estimating surds, which is a grade 10 topic. Now we'll discuss this topic together because they link, right? They basically stem from the same idea, which we talk about approximations and estimations. That's basically what we are doing here. So sometimes you don't really want to know an accurate answer. You just want a rough idea of what a calculation may become or what a calculation may be. So therefore, this is why we talk about approximation and estimations. Right? It's just an idea that we learned so that we can speed up some calculations in the real world. Right? But I will discuss the real world applications of these two topics. Before we start talking about rounding off and estimating surds, I need to talk about the place value systems, because you will always hear the question stating round up to the nearest thousands, now round up to the nearest hundreds, the nearest tens, nearest units, nearest tens, hundreds or thousands. That's where it comes from. So it's just a quick overview, something that we've done in grade 8. Very simple topic. Right, this is the basic structure of a decimal number. We call this place value system, which indicates the value of each digit based on its position. Very important. So we give each digit in this number a value according to its position, right? So the first number, let's talk about a whole number. So this part here, remember, if you watch the fraction video, you would know now that this part here is what we call the whole number part, and this part here to the right of the comma is what we call the fractional part. So let's look at the whole number part. The first digit is what we call the ones or the units. The digit to the left of it is called the tens. The digit to the left of that is called the hundreds. The digit to the left of that is called the thousands, 10,000s, 100,000s, and millions. Right? That's basically how we classify the digits according to its position. Then if you look at to the right, if you look at the fractional part, then you would say that the first digit is the tens, hundreds, thousands. So how do we get these values? So firstly, if you look at the first digit, if you multiply by 10, you get to the next digit. That's why we call it the tens. If you multiply by another 10, you get the second digit, which is the hundreds. If you multiply by 10, you get the thousands. If you multiply by 10, you get the 10,000s. That's how it works. That's moving to the right. You could do the same thing. To go from the tens to the units, we divide by 10. To go from the hundreds to the tens, we divide by 10. So you could say in either way, right? Either way, you could say it in two ways. You could say each position value is divided by 10 of the position value to the left. So each position value, like the units, can be found by dividing the position value to the left of it by 10. See, if I divide by 10, I get this, the units column, right? If I'm in the hundreds, if I divide by 10, I get to the tens, right? Alternatively, what I could say is that each position value is found by multiplying by 10 to the position value to the right of it. So this position value could be found by multiplying the position value to the right of it by 10. So if I multiply the tens by 10, I get the hundreds, right? That's basically it. But all you have to know, you don't even have to remember any of this. You just need to remember the names of these columns. So you're given a number, this is the structure of a whole number, and given a decimal, this is the structure of the decimal. Okay, so let's go to the rounding off section and let's link all of this to the rounding off. So let's talk about rounding off. Rounding off is so important in life, yet it is a topic that very few understand. I will first discuss how to round off, then elaborate on its importance and its role in the real world. You will be asked to either round off whole numbers or round off decimals. Now that's very important. And keeping these two ideas in mind is important because you have to apply yourself slightly differently when you're working with these numbers. But as I said, if you look at the place value system, when you're dealing with whole numbers, not fraction, remember what whole numbers, think about your numbers, real number systems, only look at this part. When you're dealing with decimals, only focus on this part. Okay, understood? Right, so the general steps that you will employ whether you're rounding off whole numbers or decimals are as follows. So these are general steps that you will apply even if you're dealing with whole numbers or you're dealing with decimals. These rules will still apply. They are universal. Right, So find out which digit is the last digit you are required to keep. We'll call this the digit in question. This is stipulated using the terms we discussed from the place value system, such as thousands, hundreds, tens, hundreds, or thousands. So basically what I'm saying is you will be given a question and they'll say round up to the nearest tenths. Then you'll come to this column and look at this digit. Focus on it. So this is what we call the digit in question. Then our next rule is to look to the digit to the right. So look at the digit to the right. So this is the digit to the right. If the digit is less than 5. So less than 5 means not including 5, less than 5. So it could be 0, 1, 2, 3, 4. Not 5, less than 5. Or we round down. What does it mean to round down? It means that we leave the number unchanged and every digit to the right of it becomes 0. So look here. So this number here, let's look at this number here. So let's say we were given 0,345. They say round up to the nearest tens. So round up to the nearest tens. Okay, that's the digit in question. I look to the right. That number is less than 5. What do you do if the number is less than 5? You round down. So what does it mean to round down? You take every number after the digit in question, which is the tens column, the 3 here, and you make it 0. So that is effectively 0,3. Right? Very simple idea. However, if the number is greater than or equal to 5, so now we're saying it could be 5, 6, 7, 8, 9. 5, 6, 7, 8, 9. What do? We round up. What does it mean to round up? We add 1 to the digit in question and then change every number after it to 0. So here, since this is 5, this will become 0,400. So you change this number, the digit in question, and then you make every number after it. That's why I said every number that precedes it, after it, 0. So therefore this becomes 0,4. Right, very simple idea. And now, once you understand that, we can start rounding up and rounding down. Right, lastly, if the digit in question is 9, so watch here. Let's say that we were given 0,955. And the number to the right of it is greater than or equal to 5. So see, this number here is greater than or equal to 5. So I'm still saying round up to the nearest tens. Right, so I go to the tens column, which is this column here, and I see that the number is 9. Then I also see that, I notice that the number to the right of it is greater than or equal to 5. What do you do here? You convert the digit in question to 0 and add 1 to the digit that comes to the left of it. So watch here. Very simple idea. See, this digit here is 9. The digit to the right of it is a number that is greater than or equal to 5. So we have to add 1, correct? Remember, we have to add 1 to this. But if you add 1 to this, what happens? It becomes 10, correct? So what do? Is you take the 1 and you actually add it to the number that's to the left of it. So answer here will actually be 1,000. So what we did here, we made this 10, but we actually have to add 1 to the digit to the left of the digit in question. Let me repeat that. You're adding 1 to the number to the left of the digit in question, and you're changing every number to 0 after the digit in question. So all of this here will change to 0. This, and this. That's the only 3 possibilities you can be given. With all of these rules and these few examples that I've discussed, you'll be able to solve any rounding off question. And I'm that confident. Right? But we will work with examples now to further explain these ideas. But please keep these ideas in mind. And please, I want you to take down all of these notes so that you have access to them even at grade 11. Right, so let's look at this. Rounding of decimals. When rounding of decimals, you will either need to round off to the nearest tens, meaning 1 digit after the decimal, hundreds, meaning 2 digits after the decimal point, thousands, meaning 3 digits after the decimal points, and so on. Refer to the place value table. Or you may be asked to round off to x decimal places. Here you will move x decimal places from the decimal and round off. Right, so I will elaborate on this idea. So let's look at the first example. Round off to the nearest tens. To round off to the nearest tens of 0,4526, to round up to the nearest tens, the tens is in this column here. So I look at that number. Then I look at the number to the right of it. It's 5. It's a number that is greater than or equal to 5. So therefore I must round up. What does it mean to round up? It means that you add 1 to the digit in question. So this becomes 0,5. And then you make every number or every digit after that 0. So this will be 0, 0, 0, which is effectively 0, 5. Okay, let's look at the next example. Round up 25,456 to the nearest hundreds. Okay, so which is our hundreds column? For 25,456, the hundreds column is 2 digits after the decimal point. So it'll be this digit. So it'll be one digit, the second digit after the decimal point. Here, there's it here. If I look at that number, I need to look at the number to the right of it, which is 6. Since 6 is greater than or equal to 5, it's a number that is greater than or equal to 5, then I need to make this number, add 1 to the digit in question, and make every number after that or every digit after that 0. So this will become 25,460, which is effectively 25,460. Right? Let's look at the next example. 35,2995 to the nearest thousands. So round off 35,2995 to the nearest thousands. Nearest thousands, so 435,2995. The nearest thousands is this column here. Right? It's that column. The thousands is in this column. Now this number is 9. The number to the right of it is a number that is greater than or equal to 5. So therefore, I have to do what? You have to add 1 to the digits to the left until you reach a number or a digit that is less than 9. Watch here. So this will basically become 35,3000. Because what happened here was, I added 1 here, that became 10, then I added 1 here, this became 10, so I have to add 1 here, and since this number is a number that is less than 9, then I can stop. Understood? So you will keep adding 1 to the next digit, to the digit to the left, until you reach a point where the number is less than 9. Until you reach a point where you will not get 10. It'll basically be a number less than 9. Understood? Right, that was one of the trickiest example that you could possibly get. Now let's look at the next one. 34,6, round of 34,67432 to 3 decimal places. This is equivalent to saying round up to the nearest thousands. So 3 decimal places means I want 3 decimal points after the comma. So it'll be 1, 2, 3. So basically for 34,67432, I want 3 decimals after the comma would be that decimal point. So therefore what I can do is, okay, so to round up to the nearest thousands, this is the thousands column. Now I have to look at the number to the right of it, which is what? 3. It's a number that is less than 5. So therefore, the number round down, which means that the digit in question remains unchanged. So this will be 34,67400, which is effectively 34,674. Right, so these are a list of every possible question that you could get. Right, and I'm phrasing it differently so that you can see the different variations under the decimals. Now let's look at the whole numbers. How do we deal with the case when we're given whole numbers? For whole numbers, you'll be asked to round off to the nearest ones, tens, hundreds, thousands, and so on. Look at the place value table. Exactly as I created the distinction between the whole number part and the fractional part. Now we're focusing on the whole number part only. Once we identify the digit in question, then we can follow the rules from the previous page. So let's look here, right? Let's read here. Round up to the nearest tens. So for the number 25,672, the tens column is this column here, the 7, isn't it? That's units, tens, hundreds, thousands, 10,000s. Then what we do, our next step is to look at the digit to the right of it. This number here is a number that is less than 5. So therefore we round down, meaning that the digit in question remains unchanged and every digit after it becomes what? 0. So this answer will be 25,670. Here, round up to the nearest hundreds. So for the number 25,456, the nearest hundreds, the hundreds column is where? Units, tens, hundreds. Look at the digit to the right of it. This digit here is what? Is a number that is equal to or greater than 5. So therefore I have to round up. To round up means you add 1 to the digit in question. So this will be 25,500. Right? 25,500, because this, you add 1 to the digit in question and every digit after that becomes 0. Now remember here you can't take out the zeros because it adds value there to the position, right? The hundreds column. So we're saying that the hundreds column is 0 and the units column is 0. Right, here, round up to the nearest thousands. Okay, here you have 352,995. To round up to the nearest thousands, the thousands column is here. If you look at the digit to the right of it, it's a number that is greater than or equal to 5. So therefore, we have to round up, meaning that the digit in question, we add 1 to it. And we convert every other number after it to 0. So this will be 353,000. Right. Okay, so yeah, I added another question that we can discuss, right? So basically looking at this exact same question, 352,995. 352,995. If I have to say round up to the nearest tens, if we look at the tens column, we have the number 9. If we look at the number to the right of it, we have the number 5, which is a number that is greater than or equal to 5. Now what do we do? So we add 1 to the digit in question, that'll make it 10. But instead of doing that, we actually add 1 to the digit to the left of it. That'll make this number 10. So we have to keep adding 1 to the digit to the left until we reach a digit that is less than 9. Exact same idea as we discussed with the decimals. So what would that be? It'll be 3. So what would that be? It'll be 353,000. So it'll be 353,000. So can you see how both these rounding of questions gave us the same answer, right? Just because of the way we just phrasing the question differently. Right? But it's very important that you remember in this case that we continuously add 1 to the digit to the left until we reach a digit that is less than 9. That's very important. You keep adding 1, because if you add 1 to 9, it's going to become 10. So we have to add 1 to the digit to the left. So these are rules that we must follow. Okay, so that's basically it for the rounding off. Okay, so let's look at rounding off in real life. It is also important to note that when we are rounding off in real life, you should always understand the scenario you are given and check if rounding up or rounding down seems more logical. So sometimes you may not necessarily be given an actual rounding off question where they say round up to the nearest tens, hundreds, or thousands. You could be given a real life example or a practical example or a practical question, and you need to solve it. So you have to think logically about the question. Do you round up or round down? What would seem more logical? For example, if you decide to tile or paint and you find the area of the room you intend on painting or tiling, you should always round up to account for offcuts and errors. So sometimes in construction, it's a general rule. It's better to have more than less. So you always buy extra building material than less to account for things like offcuts and maybe there's errors in the process. When you are budgeting to buy groceries and you are adding the values of the goods you intend on buying, it's better to round up the value of the goods, because if you're on a budget, you'd rather have more cash than less. So if you're looking at the cost of groceries and you see sometimes the cost of, like for example, if you're buying a loaf of bread and it costs you 19 rand 20 cents, you'll just round up and say it's 20 rand, right? Because you just want to, it's better to have more cash and overstate your expenses. That's basically what we're saying. You can even say, I say overstate expenses, understate income. That's what we say. And you can also apply this to paying for anything in general. If the price of a good is stated as a decimal, you would round up so you would know if you have sufficient cash to pay for the good. Right? So that's just a general rule and some of the examples where we'll actually use rounding off in the real world. Okay, so now let's move on to estimating surds. Estimation and approximations are quick ways of calculating answers, especially if you just want a general idea of the answer. So let's say you're at a construction site and you're trying to just get a rough idea of the measurements of materials that you need. You would always just round up, just get a quick idea. And like I said, you'll always want to have more than less. But we're actually extending this discussion to something more complicated like surds, and more useful when you go to university and you deal with engineering maths, because you start working a lot with surds. So let's say we have a complex calculation involving surds and we just want a rough idea of the answer. Then we would estimate the value of the surds and round up or round down depending on the problem. So this is how we could actually link the sections. However, let's just focus on estimating surds. So exactly like as I said, that to estimate the surds, you just want to get a rough idea of what the value is. Then you'll either round up or round down according to the scenario you are given. Exactly as I just discussed above here, about how we could rounding up or rounding down would depend on the scenario you are given. So as stated before, if you find the end root of any number and the result is not an integer, then we have a surd. I've discussed this at length in the grade 9 number systems video and the grade 10 number systems video. When we are trying to estimate the value of surds, like everything in math, when we don't have any clear way of answering a question, we always start off with what we know and try to deduce information from this. Very important. As I said, in maths, we try to simplify and solve. When we are trying to solve a problem, we always start off with what we know and move. So we move from the unknown to the known. So we move from the known to the unknown. Take known bits of information, try to draw conclusions from it so that we can answer those unknowns or find those unknowns. We must understand what a perfect square and perfect cubes are. So perfect squares are obtained by squaring an integer, and they include 1, 4, 9, 16, 25, 36, 49, 64, 89, 100, 121, and 144. The perfect cubes are obtained by cubing an integer and include 1, 8, 27, 64, 125, 216, 343, 512, 729, and 1000. To approximate the value of a surd, we simply find the next nearest perfect squares or cubes that would come before and after the surd in question and approximate its value. So we draw a number line to visualize this. So basically, let's look at this. Let's say we're looking at the square root of 13. So if we're looking at the square root of 13, the perfect square that comes after 13, let's look at the number 13, is 16. And then the perfect square that comes before it is 9. So if we take the square roots of these numbers, we can say that the square root of 13 lies between the square root of 9 and the square root of 16. That's perfectly logical. So what we can say, if you're trying to look at an actual value, we can say, we know, what do we know? We know that the square root of 9 is 3, and we know that the square root of 16 is 4. This is why we say we start off with what we know and we deduce information from it, because we know perfect squares can be found. We understand them. We've worked with it, right? Because you're just taking an integer and you're multiplying it by itself 2 times. So therefore, we can say that the square root of 13 lies between 3 and 4. Right? So this is how you write it mathematically. The square root of 13 is greater than 3. Right? The inequality sign always points towards a smaller number. So it's greater than 3, but it is less than 4. So it's greater than 3, but it's less than 4. Right? So, don't worry, we will talk about this in the next chapter. We will talk about the inequality signs in the next chapter, but this is how you write it. We say that the square root of 13 is between 3 and 4. So you can write it in words. We can say that the square root of 13 should yield the answer that is between 3 and 4. So if you look at this, and we find the actual value, it's actually 3,60555 and so on. Right? This is how you write it mathematically though. But this inequality, as I said, we will discuss in the next chapter. For now, all you have to know is how do you approximate it. You basically draw the number line and you write your answer like this. Right? But you will have, if you write your exams, you will know how to do this. Okay, so hence we say that the square root of 13 should approximately be between 3 and 4, or mathematically we write the square root of 13 is greater than 3 but less than 4. The answer of the surd is actually that. So if you're given a scenario where you have like, they tell you, okay, you know what, I'm just saying in some complicated example, they say that the square has dimensions square root 13 and square root 12. Then you know approximately you're dealing with an answer like 3,5 here, 3,5 here. Because the square root of 12 lies between the square root of 9 and the square root of 16. So it still lies between 3 and 4. Say for some reason, whatever reason, you need to find the area of this rectangle. You're given one side as the square root of 13 and one side as the square root of 12. Then you'll just say 3,5 times 3,5. I'm just saying, right? You're just going to say that. Or in the ideal scenario, we'll just round up. Because if you're trying to tell the space, you'll say, okay, I know it lies between 3 and 4, but it cannot be greater than 4, so I will take 4. Right? That's the worst case scenario. It would be 4. So 4 by 4 is 16. So what we can say that the area of this rectangle is approximately 16 meters squared. Right? This means approximately, or we're rounding off. It's approximately that. Okay, so that's basically it for estimating surds. It's a very simple section that you need to understand. All right, let's do another example. Let's say you find the value of the square root of 59. So if you look at the square root of 59, this is where you need to know your perfect squares. The perfect square that comes after 59 will be the square root of 64 and the square root of 49. So therefore we can say that the square root of 59 lies between 7 and 8. And if you find the actual value, it's actually equal to 7,68 ... whatever. Right, so you can see how you approximate surds. Very simple example. Right, in the next video, we will discuss converting a recurring number to a fraction. So if you're given a recurring number, a number that has a digit or a set of digits repeating after the comma, how can you convert it to a fraction? Given 0,3333, how does it convert to 1/3? That's what we are going to do in the next video. Okay, but for now, I hope you understand all of this that we've discussed.